Dear students, in this class, I will consider few more examples on Taylor series method, which is a single step method that we have already discussed in our previous class. So let me consider another example on solving first order ordinary differential equation with a given initial condition using Taylor series method. Problem number 3. Use Taylor series method. Use Taylor's series method to find the value of y at x is equal to 0.1 and x is equal to 0.2. Correct 2. 4 decimal places. 4 decimal places from dy by dx is equal to x squared into y minus 1 with initial condition y is 1 and x is equal to 0. So this is the problem to be solved numerically using Taylor's series method, which we have already discussed. So in the solution part, first let us write down what is given in the problem and also state what is to be done in this problem. Okay, so given y dash, that is the first derivative, y dash is equal to x square into y minus 1. Okay. Then x naught is given to be 0. I told you this is your x naught and this is your y naught. Y naught is 1 and x naught is 0. So x naught is 0, the corresponding value of y naught is given to be 1. Y naught is 1. And next value of x is at point 1. So that is the next value of x. So x1 is 0.1. Corresponding y1 we have to find out. Then another value of x, equidistant values of x. x2 is 0.2. 0.2 is your x and corresponding y2 we need to calculate using Taylor series method. So clearly your h is h is x1 minus x0 is 0.1 or x2 minus x1 is 0.1. So h is 0.1. Okay, so we need to calculate value of y at x is equal to 0.1, value of y at x is equal to 0.2 using Taylor series method. Okay. So from Taylor series we have from Taylor series we have yn plus 1, that is the value of x at x, value of y at x is equal to xn plus 1. So yn plus 1 is yn plus h divided by factorial 1 into yn dash plus h square divided by factorial 2 into yn double dash plus h cube divided by factorial 3 into yn triple dash and so on. For n is equal to 0, 1, 2, 3, etc. Okay. So I need to calculate y1 first. So y1 or y2, whatever it is, it involves derivatives. So let me find all the derivatives. So given y dash is x square y minus 1. Let I put n is equal to 0 to find y1, n is equal to 1 to find y2. So let me first find out the derivatives so that I can easily compute y0 dash, y1 dash, etc. So x squared y. So its derivative. We differentiate this with respect to x. So you get y double dash. So product rule here, product rule 2x into y plus x squared into y dash. X squared into y dash. That is your second derivative. Okay, now third derivative. Let me finish all the derivatives here. Third derivative, again a product rule here. So this is 2 into x y dash plus 2 into y, that is differentiation of x is 1, plus 2x into or x squared into y double dash, x squared into y double dash plus 2x y dash plus 2x y dash. So 2x y dash makes 4x y dash. So you can write this as 2y. You can write this as 2y plus 4x y dash plus 4x y dash. Then x squared y dash plus x squared y double dash plus x squared y double dash. Okay, so let me put n is equal to 0, 1, 0 and 1 to obtain the values, numerical values are y1, y2 at a corresponding to x is equal to x1, that is 0.1, and x is equal to x2, that is x is equal to 0.2. Okay, so I'll remove this. I need space. So put n is equal to 0 in the relation in this equation. So then y1 is equal to y0 plus h divided by factorial 1 into y0 dash plus h squared divided by factorial 2 y0 double dash plus h cube divided by factorial 3 y0 triple dash and so on. Y0 triple dash y0 triple dash and so on. So now y0 dash is x0 square into y0 minus 2. So substitute the values of x0 and y0 here. x0 is 0, so 0 square is 0 into y0 is 1. y0 is 1 minus 1, so this is minus 1. y0 dash is minus 1. Then y0 double dash. y0 double dash is 2 into x0 y0 plus x0 square into y0 dash. The substitute the values. So 2 into x0 is 0, so it is 0 into y0, y0 is 1 plus x0 square, that is 0 square is 0 plus y0 dash is minus 1, so this is 0. This is 0. Okay. Then y naught triple dash y naught triple dash is 2 into y naught plus 4 into x naught y naught dash plus x naught square into y naught double dash. So this is equal to 2 into y naught. Y naught is 1, 2 into 1 plus 4 into 0. Y naught dash is minus 1, anyway it is 0. Then plus x naught square, that is 0 square is 0. Y naught double dash is also 0. So this is going to be 2. This is going to be 2. Okay. So now substitute in 2. Call this as equation number 2. Substitute in 2. Substitute in 2. Substitute in the relation 2. So what do you get? Y1 is equal to y naught. Y naught is 1 plus h. H is 0.1. Already I have told you 0.1 divided by factorial 1, that is 1 only. So 0.1, this is 0.1, 1 plus 0.1 into y naught dash. Y naught dash is minus 1. So minus 1 plus h square 0.1 whole square divided by 2 into y naught double dash is 0. Y naught double dash is 0 plus 0.1 whole cube divided by factorial 3 is 6 into y naught triple dash is 2. Okay. So if you compute this, y1 is equal to, using calculator, so don't do manually, so using calculators, if you calculate carefully, you get 0.9003. That is, y at x is equal to 0.1 is 0.900. So the value of y at x is equal to x1 is 0.9003. Okay. Now to find the next value of y, that is y2, at x is equal to 0.2, we fix n is equal to 1 in the equation 1. So put n is equal to 1. Put n is equal to 1 in 1. Then you get y2 is equal to y1 plus h into factorial 1 into y1 dash plus h square by factorial 2 into y1 double dash plus h cube into factorial 3 y1 triple dash and so on. Now let us calculate y1 dash, y1 double dash and y1 triple dash. So y1 double dash is x1 square into y1 minus 1. So x1 is 0.1. So this is 0.1 whole square into y1. Y1 is this 0.9003 minus 1. So if you carefully calculate this one, you get minus 0.9909. Minus 0.9909. Minus 0.9909. Then y1 double dash. Y1 double dash is 2x1 y1 plus x1 square y1 dash. 2x1 y1 plus x1 square y1 double dash. So now Substitute the values for x1, y1. So 2 into 0.1, x1 is 0.1, x1 is 0.1 into y1 is 0.9003 plus x1 square, that is 0.1 whole square into y1 dash. y1 dash is minus 0.9909. So if you carefully calculate, you get y2 double dash 0.170, 0.170. If you carefully calculate this, you get 0.170. Now, y1 triple dash, y1 triple dash. So y1 triple dash is 2y1 plus 4x1 y1 dash plus x1 square into y1 double dash. x1 square into y1 double dash. Okay, so substitute the values for x1, y1 dash, etc. So this is 2 into y1. y1 is 0.9003. 0.9003 plus 4 into x1 is 0.1. x1 is 0.1 plus y1 dash. y1 dash is into y1 dash 0.1701. 0.1701. 0.1701 close the bracket plus x1 square 0.1 whole square 0.1 square into y1 double dash. y1 double dash is minus 0.9909. y1 double dash is 0.1701. Okay. Okay, if you carefully compute this, this is equal to y1 triple dash is equal to 1.4059. 1.4059. So y1 triple dash is 1.4059. Now substitute this into 2. Substitute into 2. You get y2. Substitute in 2. Substitute in the relation. Okay. So we should call this as 3. Substitute in the relation. So when you substitute in 3, you get y2 is equal to y1. y1 is 0.9003 plus h is 0.1 divided by factorial 1 is 0.1 divided by 1 into y1 dash. y1 dash is minus 0.9909 close the bracket plus plus h square 0.1 whole square divided by 2 into y1 double dash. Y1 double dash is 0.170. 0.1701. 0.1701. Close the bracket. Plus 0.1 whole cube. So right here. Plus 0.1 whole cube divided by 6 into y1 triple dash. Y1 triple dash is 1.4059. 1.4059. Okay. That's it. So if you carefully compute, you get y2 is equal to 0.8022. 0.8022. 0.8022. That is y at x is equal to 0.2 is 0.8022. 0.8022. So we got the next value of y. That is the value of y at x is equal to 0.2 as 0.8022. Okay, so we have determined values of y and specified values of x 0.1 and 0.2 with the help of initial value using Taylor series method. So let me consider another problem. On the same single step Taylor series method, another problem number 4. Employ Taylor series method. Employ Taylor's series method. Employ Taylor series method to obtain the approximate value of y at x is equal to 0.4. At x is equal to 0.4 in steps of 0.2. Steps of 0.2 for the differential equation. For the differential equation dy by dx is equal to 2 into y plus 3 e power x with the initial condition y is 0 at x is equal to 0. X naught and y naught both are equal to 0. So there is the problem. In steps of 0.2 starting from 0, x naught is 0. That is h. Given h is 0.2. H is given to be 0.2. Okay. So before we go for calculation, first we should write down what is given in the problem and also mention what is to be done. Okay. So given y dash is equal to 2 into y plus 3 into e power x. 3 into e power x. Then in steps of point 2 means h is given. H is point 2. H is given to be point 2. Okay. So then what is your x naught? X naught is, this is x naught, 0, 0. Y naught is also 0. Y naught is also 0. Then next value of y is 0 plus 0.1, 0.2. 0 plus h, that is x naught plus h is x1. x1 is 0 plus 0.2. So it is 0.2. And corresponding y1 we have to find. Then 0.2 plus 0.2, that is your next value of x. Next value of x. x2 is equal to 0.2 plus another 0.2. So that is your x naught, x2, and corresponding value of y at x is equal to x2, that is y2 is to be determined. Okay. So now, okay, so from Taylor series, write the Taylor series first. From Taylor's series, we have y n plus 1 is equal to yn plus h divided by factorial 1 yn dash plus h square divided by factorial 2 yn double dash plus h cube divided by factorial 3 into yn triple dash and so on. Yn triple dash. So call this as equation number 1. Now let me find the derivatives, successive derivatives, y double dash, y triple dash. Y dash is already given. So given y dash is 2y plus 3 into e power x. But differentiate with respect to y, we get to y double dash. This is a simple differentiation. So 2 into y dash, 2 into y dash, plus 3 into differentiation of e power x is e power x only. E power x only. Then y double dash, y double triple dash, third derivative is 2 into y double dash, 2 into y double dash, plus 3 into e power x. Since the function is very simple, we can have another term also, yn4, that is h power 4 divided by factorial 4, yn4, etc. Okay. So y, fourth derivative of y is 2 into y triple dash plus 3 into e power x. 3 into e power x. Now we have finished with our derivatives. So I have considered one more term extra because I can easily find the successive derivatives without having any problem. Okay. So now let me calculate. So now put n is equal to, I want to find y1 first. So I will put n is equal to 0 in 1. Put n is equal to 0 in 1 to get y1. So I will put this portion. So put n is equal to 0 and 1. So then y1 will be y0 plus h divided by factorial 1 y0 dash plus h square divided by factorial 2 y naught double dash plus h cube divided by factorial 3 y naught triple dash plus h power 4 by factorial 4 y naught 4 etc. So call this as equation number 2. So let us substitute for y naught dash, y naught double dash, triple dash and y at fourth derivative at x equal to x naught. Fourth derivative of y at x equal to x naught. So y naught dash is here 2y naught plus 3 into e power x naught. 2y naught plus 3 into e power x naught. So this is 2 into x naught is 0, y naught is also 0. So 2 into 0 plus 3 into e power 0. This is equal to 3. This is equal to 3. Then y naught double dash is 2y naught dash plus 3 e power x naught plus 3 e power x naught. So this is 2 into y naught dash is 3. Y naught dash is 3 plus 3 into 1. This is 3. So I get 6 plus 3 equal to 9. 6 plus 3 is equal to 9. That y naught triple dash is equal to 2y naught double dash plus 3 e power x naught plus 3 e power x naught. So this is 2 into y naught double dash is 9 plus 3 into e power 0, that is e power 0. This is 3, 18 plus 3 is 20. Then similarly, y naught 4 is 2 y naught triple dash 2 y naught triple dash plus 3 e power x naught is equal to 2 into y naught triple dash. Y naught triple dash is 21 plus 3 into 1 is 3 e power 0. E power 0 is 1. Okay. 3 e power 0. So this is 21 plus 3. 42 plus 3, 45. So y naught 4 is 45. Now substitute in 1. Substitute in 1. Substitute in the relation R2 in relation. So what do you get? y1 is equal to y naught is 0 plus h is 0.2 divided by 1 into y naught dash is 3 plus h square 0.2 whole square divided by factorial 2 is 2 into y naught double dash is 9 plus 0.2 whole cube divided by 6 into y naught triple dash is 21 plus 0.2 raised to the power 4 divided by 24 into y naught 4 is 45 etc. So if you carefully compute carefully compute, you get y1 is equal to 0.8110, 0.8110. That is the value of y at x is equal to x1. That is y at x is equal to x1 0.2 is equal to 0.811. So this is the value 0.8110. Okay. So next we have to compute the value of y at x is equal to 0.4. That means we have to find y2. So we get y2 by replacing n by 1 in 1. So put n is equal to 1 in 1. Put n is equal to 1 in 1. Okay. So then you get y2, yn plus 1 plus 1, y2 is equal to y1 dash, y1 double dash, etc. So I change here only y1 dash, y1 double dash, y1 triple dash, y1 4. Okay. So let me call this equation as 3. Okay. So let me calculate y1 dash, that is equal to 2y1 plus 3 into e power x1. 2y1 plus 3 e power x1. So I have to substitute here carefully. If you substitute, so 2 into y1. y1 is this 0.8110. 0.8110 plus 3 e power x1. x1 is 0.2 now. x1 is 0.2. So if you simplify this, if you calculate using calculator, you get 5.2862. 5.2862. So this is 5.2862. 5.2862. Similarly, y1 double dash is 2y1 dash 2y1 dash plus 3 e power x1. Okay, now substitute here. So 2 into y1 dash is 5.2862 plus 3 into e power x1. x1 is 0.2. So this is equal to, if you carefully substitute and simplify using calculator, so this is equal to y1 double dash 14.2366. 2366. So y1 double dash is 14.2366. Let me calculate y1 triple dash. y1 triple dash is equal to, what is y1 triple dash? 2y1 double dash plus 3 e power x. 3 e power x. That is y1 triple dash. So this is equal to, two into y1 double dash 14.2366 plus 3 e power 0.2. e power 0.2. So this is equal to y1 triple dash 32.1374, 32.7 right here, 32.1374. So this is your y1 triple dash. Similarly, y4 is equal to 2y1 triple dash plus 3 e power x1 plus 3 e power x1. So this is 2 into y1 triple dash is 32.1374, 32.137.4 plus 3 e power 0.2. x1 is 0.2 and this is equal to 67.9390, 67.9390. So y14 is 67.9374. Now substitute in 3. Right here. Substitute in 3. Substitute. Now I don't require this because this is the end of this problem. So remove this. Now substitute in 3. Substitute in this relation 3. Substitute in 3. So y2 is equal to y1. y1 is 0.8110 plus h is 0.2 into y1 dash. y1 dash is 0.55. y1 dash is 5.2862 plus 0.2 whole square divided by 2 into y1 double dash. y1 double dash is 14.2366 plus h cube 0.2 whole cube by 6 into y1 triple dash is 32.1374 plus 0.2 to the power 4, 0.2 power 4 divided by 24 into y14 is 67.9390. So if you carefully compute this, you get y2 is equal to 1.4164. 1.4164. So that is y at x is equal to x2, that is 0.4, is equal to 1.4164. So we got the value 1.4164. 1.4164. Okay. Now this completes the problem.
So now few more examples I think you will be able to find in my lecture notes, okay, which will be circulated to you through our e-learning center. Okay. Now let me consider the next single step method, namely modified Euler's method. Now before we take up modified Euler's method, let us first understand what is the Euler's method. Of course, modified Euler's method is an improvement made over Euler's method. Okay. The next prescribed method from your syllabus is modified Euler's method. First, let us understand Euler's method first. So, the next method, a second method, as from your syllabus, modified Euler's method. Euler's method. Let us first understand Euler's method and its geometrical meaning. Euler's method. All these methods are prescribed to solve in your particular course the differential equation of first order with given initial condition. So consider dy by dx is equal to f of x comma y with given initial condition y is equal to y naught at x is equal to x naught. Now let me consider, let me give the interpretation of this. Let me consider the xy plane, y axis and x axis origin. That y is equal to y of x be the exact solution of the given differential, be the exact R2 solution, of. Okay, let us represent by a continuous curve the exact solution or solution curve of this equation. So this is the exact solution. Our solution curve. This is also called as solution curve. The initial condition at x is equal to x naught, y is equal to y naught. Let us take this. Let us take this as x naught, and this point will be at this. Let us say this is y naught, and this point is x naught comma y naught, x naught comma. Okay. Now let us say we want to find the value of y at x is equal to x1. Let us say we want to find out the value of y at x is equal to x1. Okay? So now, since the curve is almost a straight line in a very small interval, we approximate the curve by a tangent to the curve at x naught y naught. So let me write. So just assume this is the tangent. Okay.
So there is the tangent to the curve, and this is, let us call this as x1, y1, and this is the true solution curve. So here x1, y1 is the exact value. This is the approximate value, y1 approximate value. x1 is the approximate value of y at x is equal to x1. This is the exact value of y. That is true value of true value of y, and this is approximate value of y. Approximate value of y. Okay, so let me write like this. Approximate value of approximate value of y. Okay, so now, okay, since the curve is almost a straight line, in a very small interval, that is this interval, and its length is h. This is your step length h. Okay. Interval. We approximate the curve by a straight line, by a tangent, almost a straight line. We approximate the curve by a tangent to the curve, at x naught comma y naught. At x naught comma y naught. Okay, so now the equation of the tangent is y minus y naught is equal to m into x minus x naught. M into x minus x naught, where m is the slope of the tangent. Where m is the slope of the tangent. M is equal to dy by dx at x naught comma y naught, which is same as f of x naught comma y naught. Okay, so now substitute for m. So therefore, y minus y naught is equal to f of x naught comma y naught into x minus x naught. Now on the tangent at x is equal to x1, y is equal to y1. This is y1 only. That means approximate value of y1. Y is equal to y1. So therefore, y1 minus y0 is equal to f of x naught comma y0 into x1 minus x0. x1 minus x0. Otherwise, okay. But x1 minus x0 is h. x1 minus x0 is h. Otherwise, you can remove this. A means approximate value, E is exact value. Okay. So y1 is equal to y0. x1 minus x0 is h into f of x0 comma y0. H into f of x0 comma y0. Okay. So now similarly, if you want to find the value of y at x is equal to x2, at equidistant, let us say this is x is equal to x2. At x is equal to x2, let us say this is x2. We draw a line through x1 y1 with the slope f of x1 comma y1 and calculate the next approximate value of y at x is equal to x2 and so on. So similarly, approximating, again we approximate, the curve by the line, approximate the curve by the line through x1 comma y1 with slope at f of x1 comma y1 with slope f of x1 comma y1 and obtain y2 is equal to y1 plus h into f of x1 comma y. Okay. Similarly, y3 is obtained as y2 plus h into f of x2 comma y2. Okay. And in general, yn plus 1 is obtained as is equal to yn plus h into f of xn comma yn, and this is for n is equal to 0, 1, 2, etc. So this is the Euler's method. So modified Euler's method is an improvement made over this. So let me consider now the modified Euler's method. Modified Euler's method. Modified. So in your syllabus, only this is prescribed. This is only the prerequisite to study modified Euler's method. Modified Euler's method. So again, we use this method to solve the first order ordinary differential equation of the form dy by dx is equal to f of x comma y with given initial condition y is equal to y naught at x is equal to x. Okay. Now, here we predict the value of y at a given specific value of x
by the Euler's method first.
So that is the step one. Step one, predict the value. Predict the value of y1.
That is at x is equal to x1.
Y at x equal to x1. Using Euler's method. That is the method which I
Just now explained.
Euler's method. That is y1 is equal to, let us call this as y1 0 for iteration purpose, is equal to y0 plus h into f of x naught comma y.
So using this formula, that is Euler's method, first let us find out y1 or y1 0, both are
Okay, no need replacement for this
notation.
Okay. Then in step 2, we correct this. This will be a true value, so we correct this one. Step 2, correct the value of y1, correct the value of y1 using iteration formula, y1 r plus 1 is equal to y0 plus h divided by 2 into f of x naught comma y0 plus f of x1 comma y1 0. Okay. Close it.
So in this method what we do, we first find the value of y1 using Euler's method, then we correct it by the iteration formula.
So what is the geometrical representation of this? So let me write the geometrical representation of modified Euler's method. Geometrical interpretation.
That make it very simple.
Again, you consider the xy plane, xy plane.
Okay. So consider
The exact solution, like we considered in the previous discussion, this is the solution curve or exact solution curve. Okay. Of this, consider dy by dx is equal to f of x comma y with initial condition y is y naught
at x is equal to x naught.
Okay, so now the initial condition is going to be, let us say this is x naught, this is your x naught corresponding value y naught, so this is x naught comma y naught, x naught comma y naught. Draw a tangent to the curve at x naught y naught. Draw a tangent to the curve. Let us say this is tangent let us call this tangent as, assume this is the tangent, let us call this as draw a tangent L naught. Draw a tangent L naught to the curve at x naught comma y naught, whose slope is m naught, whose slope is m naught, that is equal to f of x naught comma y naught. Let us say we are interested in finding the value of y at x is equal to x square. As you see, this is the actual value. Let us say this is x square, y1. Again, actual value of y. Okay. Then, and this is the, to determine, so let us call this as x1, y1, 0. x1, y1, 0. That is value of y at x is equal to x square. That is, we call it as y1, 0. On the line L naught, this is the tangent line L naught. On the line L naught, determine on the line L is equal to L naught, determine y1, 0. Determine y1, 0. That is the value of y at x is equal to x square by Euler's method. On the line L naught, that is tangent to the line at x is equal to x naught y naught, at x naught y naught, determine y1, 0 by Euler's method corresponding to x is equal to x, corresponding to x is equal to x, corresponding to x is equal to x. So now draw a line L1 through x1, y1, 0, through x1, y1, 0, with the slope f of x1, y1, 0, with the slope x1, y1, 0. So let us write down that. Let us say this is the line L1. Okay. Now, let us with the slope, let us say m1. If the slope m1 is equal to f of x1 comma y1, 0. Now, draw a line N2, again to the same point, N2, draw a line N2 through x1, y1, 0, with the slope equal to the average of slopes of L naught and L1, average of m naught and m1, with the slope m2, let us say this is m2 with the slope m2 equal to the average of m0 and m1. So therefore, m2 is 1 by 2 into m0 plus m1, or m2 is equal to m2 is equal to 1 by 2 into f of x naught comma y naught plus f of x1 comma y1.
Now, so N2 should be written now. N2.
Let us take this is N2. This is N2.
N2 is a line drawn to the same point with the slope equal to the average of slopes of L0 and L1. Okay, that's fine. Now, draw a line. Draw a line. L3.
Draw a line L3 through
X naught y naught through this point.
x naught y naught through
X naught y naught
with the slope
equal to M2.
with the slope equal to m2.
That means a line parallel to N2 through this distance.
That is a line parallel to N2 through x naught y naught, x naught y naught, through
X naught y naught.
so parallel to N2 through this. Okay. 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 So if you carefully draw. Okay. This is the line. So at this point, let us call this as x1, y1, 1, y1, 1. y1.
Now as you see,
This value is close to the exact value compared to the one
determined by Euler's method. That is the improvement here. That is the improvement. Okay, so we have drawn L3 through x naught y naught with slope equal to M2, but M2 is the average of slopes of L0 and L1. Okay, so now equation
of the line L3. So this is the line L3. Equation of the line L3 is y minus y naught is equal to slope is m2 into x minus x naught, m2 into x minus x naught. So therefore at x is equal to x1, at x is equal to x1
on the line L3,
at x is equal to x1 on the line L3 at
x is equal to x1. At x is equal to x1,
y is equal to y11,
y is equal to y11. Okay.
so substitute. So y11 minus y0 is equal to m2. m2 is 1 by 2 into f of x naught comma y naught plus f of x1 comma y1 0. x1 comma y1 0. Okay. That is the average 0. Okay, so therefore into x1 minus x0 into this one into x1 minus x0. Okay. So now, so x1 minus x0 is your h. Is your h. So therefore, y1 1 is equal to y0. Take it to the RHS. Y0. x1 minus x0 is h. h into 1 by 2. h by 2 into f of x0 comma y0 plus f of x1 comma y1 0. x1 comma y1 0. Okay, this is a better approximation compared to this y1 0. That is the improvement. See, you can easily see this is very far away from the exact value, and this is a bit closer to the actual value, though it is approximate value, but very close to the actual value. Okay, so similarly, y1 2 is obtained as, similarly we obtain y1 2 y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 1 and y1 3 is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 2 y1 2 and so on. So general iteration formula can be written as y1 r plus 1 is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 r for r is equal to 0, 1, 2, 3, etc. So generalizing, I remove this now. Generalizing or in general or generalizing, we can write this as yn plus 1 for different values of y, y0, y1, y2, y3, etc. For n is equal to 0, 1, 2, 3. For iteration r plus 1 is equal to yn plus h by 2 f of xn comma yn plus f of xn plus 1 comma yn plus 1 r, where yn plus 1 r is yn plus h into f of xn comma xn comma yn. Okay. For n is equal to 0, 1, 2, 3, etc.
So the modified Euler's method, we first determine value of y, say y1, let us say y1, using Euler's formula, and then we correct it using iteration formula. Okay, so now today I will stop here. I have given the general geometrical interpretation of both Euler's and modified Euler's method. In my next class, I will consider problems on modified Euler's method. Okay, thank you.